This is problem number 4 on the midpoint and distance study guide. So I want to find the distance between these two parallel lines. So the first step is to just graph them. This step's going to be easy because they're already in slope-intercept form. So I'll do this one in red. So the y-intercept is 1. And I'm going to do a bunch of points. I'm going to go up 2 over 1, because the slope's 2 over 1, up 2 over 1, up 2 over 1. I'll even go the other way, down 2 over 1, down 2 over 1. Okay, that's enough. So I'll connect those with a line. So boom, that is the red equation. Next one, y-intercept's at -3. Same slope, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, step 1, done. I graphed the two equations. Now I'm going to start finding the distance between them. Now, distance is always measured perpendicularly. So I need to make a perpendicular line. To do that, you have to look at the slopes. These have slopes of 2. So any perpendicular line is going to have a slope of opposite reciprocal. So -1 over 2. So I'm going to use the y-intercept here and start. You can pick any point, but I'm going to use the y-intercept, and I'll tell you why here in a minute. So from there, I'm going to count an opposite reciprocal slope. Down 1 over 2. Down 1 over 2. Down 1 over 2. Okay, so there is my perpendicular line. So I like that point. It's nice. It's perfect. It's 0, 1. I don't really like that point right there. That is not a really pretty point. I can't literally see what that point is by looking at the graph. I could approximate it, but I want an exact answer. So to find that exact point, I need to do a little algebra. So that's the intersection of this line right here, which has an equation of y equals 2x minus 3, and this line right here, which has an equation of y equals -1/2 x plus 1, hence why I chose the y-intercept, so I could easily write that equation. So I could choose either elimination method or substitution method here. I like substitution because the y's are already solved. So I'm going to lasso this, which that is y, and I'm going to put it in right there. So that gives me a new equation, -1/2 x plus 1 equals 2x minus 3. I'm going to do a quick solve here, so that's going to give me 4 equals 2.5 x. Divided by 2.5, I'm going to get x equals 1.6, 1 3/5. So nice, I know the x-coordinate of that point. To find the y-coordinate, just like with solving systems, you plug it back in to one of the equations. Doesn't matter which one. I'm going to plug it into that one. I'm going to do all that just on a calculator. So 2 times 1.6 minus 3, it's 0.2. So the y-coordinate there is 0.2. And you know what? That looks pretty reasonable with my graph. It does look like that point is over a little more than 1.5 and up about 1/4. So it looks accurate. Alright, so now that I have the 2 points, now I just find the distance between them, which involves the Pythagorean theorem. So if I build a little right triangle here, there's the horizontal distance, there's the vertical distance, and I'm looking for that distance. So to find the horizontal distance, I look at the two x-coordinates. There's one, there's one. How far are those apart? Easy, they're 1.6 apart. Okay, now to find the vertical distance, I look at the y-coordinates, that one and that one. How far are those two apart? Well, again, that's pretty easy. They are 0.8 apart. And so then I just have, I use the Pythagorean theorem here, because that's C. So 1.6 squared plus 0.8 squared equals C squared. Okay, I do some quick solving. I'm not going to spend much time on this. And I'm going to end up with C equals the square root of 3.2, which is approximately 1.79. And that's my final answer. If you have any other questions, ask in class, please.